So guys, let us start with the course Data Science Fast Track course. My name is Nawaz. I am a corporate trainer, consultant, and mentor. So let us go ahead with the today's agenda. Today is a day 4 of this particular course. As we know, this course duration is will be like 10 days. Okay, 3 hours each, right? So this will be a day 4, and in this particular D, we'll be talking about classification algorithms. Okay, what are the different classification algorithms we have? Why to use classification algorithm? Then we'll be talking about the different classification algorithms. We will be starting with the logistic regression. Then we will be talking about the decision trees and random forest. Also, we also talk about the model evaluation matrices like the confusion matrices, classification report as well as the ROC curve. Let's go ahead with the classification algorithm. As you know guys, this course will be a around 80% practicals and 20% only theoretical, so you can be able to hands on with the different algorithms of the machine learning as well as the basics of Python, basics of R, MySQL, Tableau, and Python, uh, Power BI, right? So see, if we're talking about the machine learning, there are three main categories, right? First one, supervised learning. Then second one is unsupervised learning, and third one is going to be the reinforcement learning. And fourth one, we have a semi-supervised learning. So this is going to be hybrid type, right? Okay. So guys, for this particular session, we will be talking about the classification algorithm. As we know, there are three main types of the machine learning. First one is supervised. So in the supervised learning, we have the two different types, or you can solve the problem of in the supervised learning. And what are those problem? First one is regression, second one is classification. So as we know, we saw yesterday about the regression. So in the regression, okay, we are trying to build the model which can predict a numerical values. Okay, like a the prediction of sales, right? Or a prediction of any price. We can say prediction of gold, prediction of temperature, prediction of you know we can talk about like a share market and all. Yeah, prediction of shares and all, right? So these are the different types we have in the reinforcement, sorry, in the supervised learning, we can say classification algorithms. Okay, if we're talking about this particular thing, okay, the classification algorithm. So here you can see that we are building the model which can predict a class. If we're talking about the the class, so we can say that the class is having the the category, different types of categories. Okay, let's say yes no category is there, then true false category is there. Like if we're talking about the another the example of the class, so we can say that you know the spam emails. In the emails, how many categories are there? The primary email, social email, okay. Then we have the you know the some kind of spam emails, okay, right? So you will find that the multiple categories in the email as well, right? So here as well, yes, in the gender, male and female categories, two categories are there which are main. Okay, so these are the things. So basically, if you're talking about the difference between the the classification and regression, so here, as you know, suppose if we have the data, so here you can see that our in the regression, our main goal is to predict a numerical values for our upcoming data set, or for just predict the future values, right? So here you can see that we have the data points with the you know we have the only data points, and here you can see that the main goal is to find out our upcoming data points, right? Let's say if we have the the sales data, okay, till the March month, okay, and we wanted to predict the, the sales of upcoming month, which is April, right? So by using previous months, we are trying to, build the model which can predict the sales of upcoming month, right? So that we saw in the regression. Now what is in classification? So in the classification, you will see that, okay, there is, binary class classification problem is there, there is multi-class classification problem. So if you see this particular plot, so in this particular plot, okay, if you see this particular plot, so here you can see that the two different, colors in the data points, first one is red, second one is sorry, first one is green, second one is blue, right? So here you can see that there are two different colors, which means that there are two different classes in my data set. Yes. So I have to, classify these two classes by using some mapping in between that. Okay, there is something, okay, or some, conditions are there, or some, mathematical concept is there. With the help of that, we can be able to, classify that data into the two groups, okay, or into the two different classes, let's say the green class, or let's say the blue class, right? So here you can see that, okay, we just build the model of classification, okay, like just don't imagine this thing in the, not just the, the two dimension. If we're talking about the, let's say we have the data of, the 10 columns, let's say at least 10 column we have. So we can't imagine the, 10 dimension data, right? We up to 3 dimension of the data we can able to visualize, but we can't visualize the 10 dimension data, right? So here, okay, just to understand the concept of classification, okay, here this plot, from this plot you will understand what is classification. So here in the real life you will find that the few data points, okay, of the, blues as well as the few only from the green also are here in this particular blue region, let's say. Also here you will find that the most of the data points are nothing but the green, and here also you will find that the most of the blue data points, okay, which means that, okay, like there is, like many times, okay, when you are dealing with, uh, real time data, so at that time you will have to, you know just understand that you will, very rarely get the 100% accuracy, right? So that is the thing, okay. So these points, this, this, out of this most of the green data points, you will find that the few blue data points, so those are nothing but your misclassification, right? In the same way here you will find that the green data points, which are few data points in the blue region, or most of the blue data points, right? So guys, let's understand about the classification algorithm in more detail. So that's why we will go further and we'll try to understand the different algorithms of classification, right? Okay, so let us talk about the linear regression versus logistic regression. Okay, so guys, as you know, what is linear regression? So here you will see that, okay, this right plot is going to be, let's say, linear regression, right? So here you can see that our data is different now. Our data is different, right? So this is my data. So basically you have, let's say, X and Y data. You have the two classes, right? So but your label is nothing but your Y data, right? As we discussed yesterday, or let me show you on the, whiteboard, so you will understand this thing. Now guys, as you know, if you are talking about the regression problem, so here you will see that the data set like this, either this, or, in any other, this is the upper trend data set that I am drawing. Okay, you may get a data set in the downward trend or the the non-linear pattern as well. So let's say this is my this is my regression line and this is my data, right? And I have created a regression line which is going in this particular in between these data points, which is exactly middle. Okay, now this is going to be the x coordinate, this is going to be the y coordinate, right? Okay, data, and this is how I build the model of the regression. Now let us see if we got the data like this. Okay, if we got the data like this, okay, this is my x coordinate, this is my y coordinate. Now you will see that, okay, you will get the data in the range of, let's say, starting from 0 to, let's say, 100. But here your target variable is not the continuous one, it is going to be the, let's say, discrete one. Okay, like let's say, let me assume this is, okay, here is my 0, okay, to show you, just to show you. Okay, and this is one value. Okay, and now we got the data like this, few values are over here in this particular region and few values are over here. Okay, as we know, we got the data like this, x values which are, okay, let's say 32, 22, okay, 41, 56, okay, then 78, okay, in between 0 to 100, right? And your y data is like this, 0 1 1 0 0, right? So which means that if you plotted that data, so your data is not visually correct, you can say. So you can simply say, okay, if we write this particular data, so okay, this is my data over here in the regression type of problem. So again the same, okay, let's say 11 42, okay, then 53, I would say, then 24, like this. Okay, then 66, like this. And here you will find that the same kind of thing. Okay, 21 32, okay, 61, right? 25, okay, 78, like this. Okay, so here you will find that, okay, my y data is also somewhat continuous, you can say, right? So okay, and this also is continuous manner. Okay, let's say this is my the, let's say, age, okay, column, and this is going to be the, let's say, any column. uh let's say the column is going to be the height, let's say. Okay, height column is there. Okay, so this is my age and this is my height, both are continuous one. So you will see the data like this, right? Now if we're talking about the classification one, you got the data like this, x data, right? The y data, okay, this is your y data, right? But here you will find that in your y data looks like this, 0 and 1 format only. There are only two classes, 0 and 1. Okay, so apparently, okay, after plotting scatter plot, so you will find that your data looks like this. Okay, few values over here and few values are over here. Now if you plot, okay, if you plotted the regression line, so you will see that your line looks like this, right? Your line looks like this. Okay, which is not the perfect equation for this particular problem, for this particular data, right? So for that you will have some kind of data or some kind of model like this, right? So you will have the data like this. Let me show you again over here. Okay, you want the model like this. Okay, so here in the PPT, if you okay, if you see, so here I'm trying to, okay, show you the same thing, right? I'm trying to show you the same thing. Understood? Okay, this is my regression problem. If we are using the regression on linear regression for this particular kind of data, so this won't work. So at that time you will have to use the logistic regression, right? So in the logistic regression, how we just created this particular line, okay, what are the different transformation we applied on this particular linear line, so we just able to convert this line into the S-shaped curve. This is somewhat like S-shaped curve, isn't it? Right? So this is my logistic regression, right? So in the name itself there is logistic, which means that I have used logist function over there, right? I have used logit function over there, right? So okay, let us understand what is exactly logistic regression is in the in the deep way, so you can be able to understand this thing, right? So this is going to be my sigmoid function. And what is this, guys? Okay, this is over here you can put your regression line, our regression function. Let's say your function of x, which means that y equal to beta naught plus beta 1 x. Okay, this is the just the simple linear regression I am talking about. If you're talking about the multiple linear regression, so you can add the terms like this, beta 2 x2 up to so on beta n xn, right? So this is nothing but the function of x, isn't it? Is this a function of x? This is a linear combination of the your coefficients and your columns, the features which are there in your data. Okay, so that is nothing but it is a function of x, f of x, right? So you can use these over here. So 1.1 plus e raised to minus f of x. So this is going to be your sigmoid function. Okay, let's say you have the x like this. Okay, the 1, 2, 3, 4, 5, 6, so on. Okay, and you are using this sigmoid function, right? Sigmoid function is like this. Sigma of x is going to be the, you can use this formula, you can use this formula, you will get the values, some values, right? You will get some values and the plot for these values will look like this. The plot for this particular column, right? So that is the power of sigmoid function. Okay, now one more thing here over here is, okay, this sigmoid function is very much important. Okay, why I wrote this particular sigmoid function is because if you see that in our in our previous problem, the values for y are this 0 and 1, right? There are two values, okay, which are nothing but the 0 and 1. So if you wanted to find the probability of 1 and probability of 0, so at that time this probability has nothing but the, you can calculate by using the p of x, okay, which is equal to 1 divided by 1 plus e raised to minus f of x. Okay, and this will give you the, probability of class 1, right? And if, okay, and in short, okay, this is a probability of x. In short, I will write, okay, like this, x equal to 1, because here you will find this, but in the continuous manner you can't write this, okay, because it's a equal to sign, and in the continuous probability you will find that if you write this, so which means that its value will be 0. Okay, that's why I'm ignoring this thing. So that's why I have just written over this like this, right? So just, forget about this, because okay, this is not possible to write, okay, and the write the probability in the continuous manner like this. Okay, so here you can see that the 1 minus probability of x is going to be the probability of So you can simply use this. And what is this guys over here? This is just a simple linear regression function. Okay, let's say if I have, okay, let's say this is my problem, y and x problem we have. So I can simply write the model for this is going to be the beta naught plus beta 1, okay, x. This is simplest model I can say. Okay, I can use this particular model. Okay, I'll write this particular model over here and we'll get the model like this, okay, which is a S-shaped curve, right? So let's go over here, okay, and here you can see that, okay, now we got the values, okay, in terms of you will definitely get the values in terms of y, either y equal to 0 or y equal to 1, right? So this is the thing over here. So that is what I am trying to show you over here, okay, either in this particular plots or in the whiteboard as well. Okay, if you see over here, okay, so here you can see that, okay, this is my linear regression. Okay, this is my linear regression. So if you see over here is, okay, if you see over here is, okay, the error you see, okay, is very less. Error is nothing but the distance between your original data points and your regression line, your predicted data points. But if you see over here is the distance now, okay, is very less as compared to this distance. If you plot the regression line over here, so you will find that for this particular data points, distance will be very high. Distance will be very high. So it can't predict the right output, right? It can't predict the right output because the aim of the regression model is to predict the continuous values or the continuous data. Okay, so you will find that it will definitely predict the values from, okay, if your data looks like this, so it will be able to predict the values from here, okay, like this. But if let's say if you build the regression model over here for this particular data, so you will get the values, let's say, okay, you will, let's say you will get the values from here. Okay, so you will find that the value of y is 1, but you will get the value from here of here, okay, which is not the correct value because the y values, okay, are just the two values, like the 0 and 1. Only two classes are there for y, right? So that is the problem with the regression model over here. Okay, that's why you will have to apply the sigmoid function over here and it can be able to predict the values either 0 and 1. Okay, and it can predict the values in the form of probability, in the form of probability. Okay, not the exact value, not 1 and not 0. So now let us go ahead and let's do some practical so you will understand in more details, right? Let's do some practical. Okay, I have shared you the the data, okay, which we will be using for this, but I guess not for the logistic regression. Okay, we will be using this particular data for the decision tree and the random forest. Okay, we will be using, okay, we just creating a dummy data for the logistic regression, right? So guys, let's create the dummy data. Okay, see guys, okay, uh, you know when we are dealing with this thing, okay, like when we are dealing with this thing, okay, why we, okay, let me ask you a question. Why we are creating the model? Why we are creating the model? Our aim is to predict the value, right? Either value in the form of numeric, okay, which means the continuous data, okay, either or in the form of classes, 0 1 class, right? So this is our main objective to build the model, right? So if our data is continuous, I'm talking about y, okay, if okay, I'm talking about y data, which means our main target column that we want to build the model, okay, which can predict our target column. Okay, so if we're talking about our y data, if our y data is continuous, right, if our y data is continuous, so we'll have to go with the regression algorithms, right? We'll have to go with the regression algorithms, right? And if your data, if your target data is the labels or the class data, so which means that only two values are there, only three values are there, only four values are there, which means that that data is the label data. Okay, that data is nothing but the label data. That's why you will have to use the classification algorithms, right? So here I'm talking about the error, because if you are using the regression methods or regression algorithm for the classified data, for the label data in the form of discrete, your target is discrete, so it's not possible. At that time you will get the very high error, right? So if you are using, okay, the regression over here, this is not suitable. If you are using the any other classification model, that will be suitable over here, right? So that is the thing. Okay, now guys, let us go ahead and talk about the logistic regression. So here I just rename this particular notebook as the classification algorithms, right? Classification algorithms. Okay, so as we know, first classification algorithm we will see, which is nothing but logistic regression. Okay, so guys, as we know, we have to import few libraries, right? So what are those libraries? As we know, first we'll start with the pandas as PD. Not understood your question. Why? What do you want to say? How do we get the title in the notebook? Okay, here you will find the the like acha, you want it. Okay, you want this kind of title. Okay, if you want this kind of title, you will have to convert your coding cell from the markdown cell, right? This is my coding cell. Okay, I just converted this coding cell in the markdown cell and I got the title, right? So this is how you can create the title. Okay, here what we are doing is we are, okay, importing the libraries, okay, which are important for our analysis, right? Then second we have the import numpy. It's not the comment, it's the code. So I'll have to go with the directly import numpy as np, right? Third library is going to be the import matplotlib dot pyplot as plt, right? And what will be the fourth one? For creating a classification model, we will have to import the fourth library, and in Python the most important library for the machine learning algorithms, which are nothing but the sklearn library. Okay, we will be using a stats model library for regression, okay, not for logistic regression. Yes, there is some confusion because of the over the name over here, which is regression, but you will find that logistic regression is the only regression algorithm, okay, which we will be using for the classification. Okay, this is not the, we can't solve the problem of regression by using logistic regression. Logistic regression is solving the problem of classification. Okay, and this is the only model which we can use for the the classification. It can do only one thing, classification, not the regression. We have a lot of multiple models, okay, which we can use it for the you know the classification as well as the regression one. Okay, as we will talk about those as well. like the decision tree and the random forest. We will be okay understanding those model in the same session. Okay, so guys, okay, so that's why let's go and import sklearn dot linear models. Okay, dot linear model, and from here we will have to import the logistic regression. Okay, okay, logistic regression. Now guys, I just wanted to show you the some shortcut for this. Okay, pyplot is not the sub library, is the one module in the matplotlib. With the help of pyplot you will be able to draw the plots, okay, with the very less code, right? So that's why we will be using that particular matplotlib. Okay, dot pyplot. Now second thing is that if you see the if you wanted to import some particular, let's say, module, okay, or the model from the library, so what you can do is you can simply, if you wanted to sometimes like there are a lot of algorithms are there, lot of models are there, and we don't know, like the sometimes we just forget that particular model that we want to import in that particular case. So what we can do over here is, so sklearn, we can simply after dot, okay, like right, we want to go with the linear models as we know, so we can simply use the tab. Okay, if press the tab and you will see that, okay, see here I use the the tab. Okay, and now here you can see that the so many all the modules which are there in the sklearn. See, are you able to see this? Just use the tab, right? So my aim is to import the linear model, right? Right, so here I'm gonna import. Okay, so this is the from, I guess, not the, okay, from sklearn dot linear model import, which one, the, again, logistic regression, like, right? So just press the tab over here and you will get the all the list, right? Logistic regression. So here you can see that you will be able to go with this thing, logistic regression, right? So this is how you can import the the model from the library. So sometimes you will find that the for the names logistic regression you will find that the L is capital, R is capital. Okay, sometimes you are getting some error. Okay, let's say you just go with the lowercase, all this word is in the lowercase, and if you go with this thing, so it will definitely throw an error, right? And what will be the error? Logistic regression is not defined, okay, in this particular library, right? This is not a regularization technique. Okay, this is a cross validation. If you wanted to explore your most of the data, so at that time you can use this. That is nothing but a sampling technique, one of the sampling technique, you can say, right? Cross validation, so which means that you will be getting, okay, let's say if you go with a cross validation 5, so which means that, okay, the model will automatically split your data into the 5 parts, right? And after that 5 parts, it will take the first 4 part into the train, okay, and last part into the test. So it will build the model by using the first 4 part and the predict the model by using the last part. In the same wise, it will again the revise your model, like it will take the first 3 and the last 1 part in the model for the training, and the fourth part as the testing. So likewise it will give you the 5 accuracies. Okay, so which accuracy is better? Okay, so you can, okay, if someone, okay, some give you the accuracy more than 90%, so you can simply take that instead of taking the any other samples, right? So that is the thing. So guys, let us go ahead with this, and after this guys, see, okay, first thing is that, okay, we are, okay, using this particular thing, this two library. First library is to read the data and pre-processing it. Second library is to let's say create the arrays, numpy arrays. okay, and doing some statistical analysis, right? Then third library is for the data visualization, right? And fourth library is for the building the model, okay. And what else is remaining? After building the model, we need to evaluate the model, right? So for evaluating the model, okay, we need to import the evaluation matrices, right? So here we will be importing the evaluation matrices. Let's go with the sklearn, right? Dot, here you can see, okay, we will be talking about the matrix. We will be talking about the matrix, okay. I'll be showing you how you can do this thing, that's why, okay. Import sklearn dot matrix, okay, and from sklearn dot matrix import, not the capital, import, the first is nothing but the confusion matrix, you know, the confusion matrix you can see over here, right? And second one, I just wanted to import the classification report, right? So I can show you the, you know, that report, so which can define the how strong your model is by using the different evaluation matrices like accuracy, F1 score, precision, recall, right? So guys, let us go ahead and import these libraries. Let's go and execute this particular cell, okay. Let's run this cell. After this, let's go and import this particular they read the data, okay. Now here, instead of reading the data, what we are doing is we are simply creating a sample data, okay. We are creating a sample data which is very you know small data, I can say, okay. So what I can do is, okay, I'll be using the X data, okay. This is my the independent feature, I can say. And I'll be using the NumPy library for creating the data, and I'll be using the np.arrange the 10, which means that it will arrange the the 0 1 2 up to 9 values, okay. And I'll be reshaping it, okay. I'll be reshaping it into the -1 to 1, which means that, okay, if we simply go with the np.arrange 10, so you will get the data in row, okay. If you reshape it like this, so you will get the data in as the column, okay. So again, see here, npy has no attribute arrange, so I'll have to go with the arrange, okay, not the 2 hours, right? Then let's you know create a y data, right? np dot array, okay. And here you will see that I'll be adding the list of my classes, yeah. So here, as we know, we just created a 10 values in the X data. So here also I'll have to create the 10 values. So as we know, okay, here in the Y column, okay, Y column is nothing but my target column. Okay, so here you will see that I'll be adding the 10 labels in, okay, either 0 and 1. So here you will see that the 4 labels are 0 and 6 labels are 1, okay. So this is the thing. So here you can see that if you go with the X, so this is my X, okay. This is my X. If you wanted to see the Y, this is my Y, right? This is my Y. Now you can see that, okay, it has a single singular list, you will see, and then comma, okay. So that is the that is why I did the reshape over here, okay. And here you will see that this is the single list, okay. And here inside the list you will see that the singular list, okay. So that is thing. Now here you can see that the second output, okay, second row you can see. So if you see that the probability of this, okay, 0.62 is greater than probability of 37, right? Probability of 37. So we can simply say that probability, okay, of this is greater than this. So which means that, okay, we got the class 0 as my prediction, right? So here, we'll have to, compare these two probabilities. There is no threshold value for this, right? We will have to compare this thing. Okay, if this probability is greater than this probability, then you can simply put prediction 0. Okay, and let's say, okay, here you can see that the last row. So okay, so this probability is less than this, because this probability is 0.97. So which means that this is the probability of class 1. So you can say that just make the prediction as class 1. What is the problem here? We are trying to solve the problem of two class classification, isn't it? Right? So if we have the two class classification, we'll get the probabilities only two. Okay, either for class 0 or for class 1. If we have the 4 class, you will get the 4 columns. If you have the 10 class, you will get the 10 columns, right? So how many columns you have, okay, how many classes you have in your problem, these many columns you will get, and you will have to compare this much, okay, this many probability. Let's say you have the 10 columns in your one row. So you will have to compare the 10 probabilities, and whichever probability is highest, you can make the prediction as that particular class, right? As that particular class. So that is the thing over here. Okay, so first column is referred to as a class 0 if the probability in that particular column is greater than the probability from this particular column 2. So which means that, okay, your class 0 is your correct prediction, right? So here, for the first three values, for the first three rows, you will see that probability value for, okay, in the first column is greater than the probability values in the second column, which means that you will get the first three values, the predicted values, as the class 0. Okay, and you will find that from the fourth row to the last row, you will find that, okay, the first column's probability value are the less than to the probability values in the second column, you will see. Okay, so you will get the probability, predicted values are nothing but the one for starting from, okay, for the row 4 to the last row, which means from the fourth position to the 10th position. Okay, there are multiple ways to find out the accuracy. So first thing, you can find out the accuracy like this. Okay, just the model dot score is nothing but the accuracy for this, your x data and your y data, and you can see that your accuracy is going to be the 0.9. Like if we have the 4 classes, so at that time you will have to, you will have to check that particular row. Okay, because here we will be checking according to rows, not the how many columns are there. Let's say there are 4 classes. Now you will find that there will be 4 columns. Okay, if you go with the predict probability, and you will have to, go with the rows to understand this, to make the predictions about either 0, 1, 2 and 3, because there are 4 classes, right? So starting with 0, then 1 class, 2 class, 3 class, means total 4 class are there, right? So you will have to compare the 4 probabilities in the 4 columns in the first row first. Okay, and which probability is showing a, highest probability in between those 4 probability, that probability, okay, that class will be the predicted class, right? Okay, now this is my accuracy. Now second thing is that I just wanted to find out the confusion matrix. So this is my confusion matrix, right? So guys, let me make it markdown cell for this, and let me explain the confusion matrix over here. Okay, explanation of confusion matrix, right? So here you can see that in the confusion matrix, see, this is a 2 class classification problem, right? How many classes are there? Okay, only two classes, 0 and 1 class is there, right? So that's why you will get the confusion matrix as a 2 cross 2, right? As a 2 cross 2. So here you will see that, okay, let's say this is the confusion matrix. Okay, this is very important, guys, because in the name itself you will see that the confusion name is there, so it's very confusing. Okay, so we will have to focus for this particular thing. Okay, so first thing is going to be the 3 value is there, right? First thing is going to be the 3 value is there. So we can say that, okay, the 3 value is nothing but the true negative. Okay, true negative. So in my confusion matrix you will see that the 3106, right? This is my confusion matrix. Okay, so this is my confusion matrix. 3106, right? Am I right? See, 3106 is there, right? So here you can see that, okay, usually in Python you will get the confusion matrix like this, true negative. Okay, why true negative? Because, okay, this is my confusion matrix. Okay, this is going to be the true negative, this is going to be the true positive. Okay, and here you will see that this is class 0, this is class 1, this is class 0, this is class 1. Okay, and this is going to be the the incorrect prediction. So this is going to be the false positive and this is going to be the false negative. Okay, we'll be coming to this particular point. Okay, now let us talk about the true negative. Here we got the value as a true negative equal to 3. What does this mean? So for that, let me show you the original y data. Okay, my okay, let's guys see in my original y data, in my original target you will find that the 40 and 61, sorry, in my y data you will find that the 40 and then 61 is there, right? And okay, let me write it over here. Okay, in my original y, the actual y I can say, actual y is there, you will find that the 0 0 0 0 4 zeros and then 1 1 1 1 1 1, total 6 ones are there. But in the predicted y you will find that, okay, in the prediction you will find that only 3 zeros are here and then 7 1 are here. So let me go over here, okay, and write the 3 0, okay, and 1 2 3 4 5 6 7. Okay, so this is the case. Now let's compare it, let's compare the actual y values with the predicted one. Okay, let's compare this thing, right? So here in the true negative, okay, true negative means okay, the class 0, positive means class 1. Now here you can see that in the actual y you will find that the first 3 zeros will be, okay, first 4 zeros, okay, first 4 values are 0, but here in the predicted you will find that only 3. So if you compare with the 3, so you will find that, okay, these 3 are the, out of 4 negative classes you will find that the only 3 correct predictions are here, right? So this value is the, we can say that the correct negative prediction. So guys, what about next? We have the false positive. Now here you can see that my false positive is 1. Okay, so here you can see that, okay, the next one, okay, total how many negative classes are here? 4 na. So 3 are the, okay, 3 got the correct prediction, right? But for the fourth one there is incorrect prediction, right? So we can say that this is going to be the incorrect negative prediction. Incorrect, negative prediction. Okay, so false positive, which means that, okay, this positive, okay, this one class here, you can see this one class is false. Okay, this one class is false, right? That's why false positive is that one is stands for positive, so that's why false positive is this. Okay, now what about next, false negative? Okay, you will find that the false negative value is 0, right? So which means that, okay, here you will find that, okay, actually we have the 6 positive classes value, right? But here, okay, we got the predicted values for all the 6 as the class 1, which means that this, for all the positive classes, you will find that the correct prediction, right? For all the one value, you will get the predicted value as the 1, right? So that is nothing but the correct prediction for your positive class. But here we don't find any, incorrect prediction for our one class. That's why the value is 0 here over here, right? So here you can say incorrect negative class, positive class, right? Incorrect positive prediction. Okay, and lastly we have the true positive. The value for true positive is 6. So this is my true positive 6. So here you can find that, okay, the actual y values, the actual positive values are 6 values. Total ones, how many ones are there? 6 ones are there. Okay, and the how many predictions are there for ones? Okay, you will find that here 6 one value are there, but the total 7 ones are there, because here one, okay, the extra one is for this particular 0 class, right? Okay, and the, the another 6 one classes which are the predicted one, these are nothing but the correct prediction for the actual one classes. So that is why you will see that the 6, which is nothing but the true positive, right? So here you can see correct positive prediction. So in the name itself you will find that there is a confusion word is there. Okay, so don't try to be, don't confuse in that particular matrix. Okay, because there are only, okay, if we talk about the only 2 classes, so you will find that the confusion matrix, okay, of order 2 class 2. Okay, if there is a confusion matrix of, let's say, let's say we have the, okay, the 10 classes like this, so at that time our confusion matrix will be 10 cross 10, right? But here our case is only 2 classes are there, 0 and 1. So that's why our confusion matrix is 2 cross 2, and it is very simple to understand. Guys, understanding is very much important. Okay, only the understanding is there. Okay, if you know the what confusion matrix is, what these values are, okay, then it will be very easy, okay, to understand all about the confusion matrix, okay, and the upcoming evaluation matrix, which is nothing but the classification report, right? So in the classification report you will see that accuracy, F1 score, precision, and recall. Okay, so let us go and calculate that as well. Okay, so if you are, missing some concept, so because see, when I'm coding, so at that time, I'm just writing the code, nothing else. Okay, when I'm explaining something, so which means that, I'm not doing the coding at that time. Yes. Yes, absolutely. Sometimes it might be, difficult to, do the coding as well as, understand the explanation as well. But it will be very helpful for you, right? Like in the first, it will be, difficult to understand this, both the things here, understand the concept as well as do the coding, right? Yeah, the beginning part of the today's class is just the introduction about the what classification algorithms are and why we are using the classification algorithm. That's about it. So if you missed it, don't worry. Okay, the recordings will be there on YouTube, but I know why, but it is generally it will take 2 to 3 days to upload the recordings on YouTube. But I don't know why they are not uploading. Definitely you will get the I'll discuss with my team and then get back with you. So I'll tell you what is what is the problem. So guys, uh, let us understand the classification report. Okay, this is the code of classification report. This is the one line code. You can see, okay, I got the classification report which is which is not in a proper format. Okay, so for that what I can do is I can simply use the print. Okay, now you can see. Okay, so here we got the how many things? We got the precision. Okay, we'll talk about that. What is precision? We'll talk about the recall. Okay, we'll also talk about the F1 score. We'll talk about the support. We'll talk about the accuracy. Okay, and these are the macro average. These are the weighted average. Okay, these are the not important thing I can say. Okay, we will be talking about the accuracy, the F1 score, precision, recall, and support. Okay, so the start with the simplest one, right? First, start with the simplest one. As we know, guys, what is support? Okay, so for that, how many data points are there in my data set? As we know, there are total 10 data points are here in my data set, right? So you will see that just 4 plus 6 equal to 10, right? So here you will see that, okay, in my Y, how many zeros are there? Okay, how many zeros are there? 4. How many ones are there? 6. So that's you will see over here. Okay. How many class 0 values are there? 4. How many class 1 values are there? 6. Okay. So this is the support. Support is nothing but the number of observation from the class 0 and the number of observation from the class 1. Understood this term support? Now let's go ahead with the accuracy. What is accuracy? Like I know guys, you all know about the accuracy. Okay, let us assume that all of you know about the accuracy. So what is accuracy? If we're talking about the accuracy, so here you can see that, okay, like let's go over here and understand this. So here see actual, how many actual values are from class 0? 4 values are there. How many actual Y values are from class 1? 6 values are there. So out of 4 class 0 values, model just predicted the 3 class 0 values correctly and one is incorrect prediction is there, right? Out of 6 1 values, okay, model predicted the 6 all 6 values which are correctly predicted by the model, right? So there is only one incorrect prediction is there. So here how many correct predictions are there? Total 9 correct prediction in the in the confusion matrix. If you sum the diagonal value, so you will see that 3 plus 6 equal to 9. So okay, these diagonal values which are nothing but the correct prediction, right? These diagonal values are nothing but the correct prediction, right? And if we're talking about the non-diagonal values, so if you sum this non-diagonal values, so you will find that the one non-diagonal value is there. So here accuracy equal to, okay, how many correct predictions are there? Total 9 correct predictions are there, because 3 plus 6 equal to 9, right? Divided by how many observations are there? Total observation, total 10 observations are there. So your accuracy will be 0.9, right? Your accuracy will be 0.9, isn't it? Which means that, okay, your model 90% of time your model is correct, and only 10% of the time your model, showing you the incorrect predictions. Okay, now what about precision? What about precision? So in simple words, okay, precision is nothing but the accuracy of your positive predictions. If you are talking about the class 1, okay, if you are talking about the class 1 is the positive. Okay, if you are talking about the class 0, so you can say that the accuracy of your class 0, the prediction of class 0, right? So precision in short is nothing but the accuracy of your class, either class 0 and class 1. So you will find that, okay, for this data, okay, precision, which means the accuracy for class 0 is 100%. Understood? What about next? Okay, here for class 1, there is 86% accuracy. Model is able to predict class 1 values 86% of time. Okay, so that is the accuracy of the class 1. Okay, what about the recall? What about the recall? Now basically, recall just measures the completeness of your predictions. Okay, recall just measures the completeness of your predictions, which means that here you can see that we got the 0.75 as a recall, which means that the 75%, okay, your class 0 is, model is able to find out the 75% of that, or the completeness of your class 0. Okay, what about class 1? 100% of the time. Okay, so 100% of the time model is able to find out the positive predictions. Precision basically you know measures the accuracy of your either positive predictions or negative predictions. So I can write the accuracy of your class prediction, right? Class predictions. What about next? The precision. Basically, precision, okay, measures the completeness completeness of your class prediction. So precision, we can simply say the accuracy of your class predictions. Okay, either class means 0 and 1 class, right? Okay, what about recall? Recall measure the completeness of class predictions. Okay, true positive. Okay, that's great to see. Okay, true positive plus false positive, right? So here you can see, okay, my true positive is how much? 6, right? How much? 6 is there. So let's go ahead with the calculation. Okay, so simply what I can do is I can write the formulas first, and then we'll do the calculation itself in the Python, so we can cross check, okay, with the formulas and these values, right? So true positive plus false negative is there, right? So these are the two formulas which are there for the precision and recall. Okay, you can use it for your reference. Okay. Mm, Again, simply use like this, enter it. Okay, now let's go ahead with the precision first. Okay, so what is our true positive? Okay, what is our true positive? So here you can see that the 6 value is there. Okay, so 6 divided by, okay, then we have the true positive plus false positive. Okay, we have the true positive plus false positive. So here you can see 6 divided by 6 plus 1, and let's go and enter it, and let's round this, round, okay, up to 2 decimal points, 0.86. Okay, so here you can see that the precision for class 1. Okay, if you wanted to find out the precision for class 0, so what is the formula now? Okay, as we know, this is the formula for class 1. Okay, this is the formula for your positive class. What about negative class? Now the precision value for this particular negative class is going to be the true negative divided by true negative plus false negative. Okay, now this these formulas which are for, okay, class 1, or you can see that the formulae are for class 1, or in short you can say that the your positive class, right? So that's why you will see that the true positive is there, true positive is there, true positive is there, true positive is there, right? Okay, if you wanted to find the the formulas for the class 0, right, the for formula for class 0, or in short your you know negative class, so here just add the true negative here. Okay, true negative, and this is also false negative, not the false positive. Okay, and here recall for class 0 is going to be the true negative divided by true positive plus false positive. Okay, so this is the formula. Okay, so you will have to you know understand these things as well. Okay, formula will be changing for class by class, right? So this is for class 0 and this is for class 1. So this is first the, I would say, the precision for your class 1, right? Or class your positive class. That's why I mentioned the 1 here, remember. Okay, and precision 1. So here you can see this thing. Okay, then what about your recall? Okay, let me do the same the precision recall in this particular cell as well, so you will understand. Okay, that's why what I can do is I can use the uh, no, I can simply add the one more cell over here, so you will understand. Okay, separately it's better. Okay, let's put recall. Okay, and here also just put the recall for class 1. Okay, now here as we know the formula for class 1, okay, and the formula for recall for class 1 or your positive class is going to be the true positive divided by true positive plus false negative. So which means the true positive divided by again true positive plus false negative. So now here we got the formula like this: 6 divided by 6 plus 0. Okay, this is my recall formula. Okay, this is my recall formula, right? Now what about the formulas for class 0? So here these are the formulas for class 0. Let me create the new cell. Okay, These are the invalid syntax. I'll just make it markdown cell. Okay, now here you can see that, guys. Okay, the recall value for class 1 is 1. Okay, you will find that the recall value for class 1 is 1, this thing. Okay, correct. So here we just cross check that the record value is 1, and recall value, basically measures the completeness of your class prediction, of your positive predictions, right? That is the thing. Now let's go ahead and find out the precision and recall for your class 0. Okay, so you can simply copy this thing over here, right, and make it 0 only. Okay, make it 0 instead of 6. You can mention the true negative, which is nothing but the 3. Here you can see in the confusion matrix, true negative is going to be the 3, right? Then what about next? Okay, the true negative, which means the 3 value is there. If the recall formula is wrong, then we will never get the correct value. You will see that we got the value for the class 1, which is 1.0, which is 100%. So here you can see that the for class 1 the value is 1. Okay, so how you can describe the recall formula is, you know class recall formula was wrong. Yes, that's why the name for the confusion matrix is the confusion matrix. So you know sometimes people will confuse in false positive and false negative, right? Okay, you will have to understand these all the things, then you will know what is recall, what is precision is. Okay, and this precision and recalls for are different for each class. So here you will find that the formula for the class 0 is different, right? So here let me show you, this is the false negative now. Okay, the false negative is going to be the the going to be the 0 here. So let me go ahead with, okay, false negative is going to be 0 over here. So you will find that the precision value, yeah, so here you will see that the for class 0 precision value will be 1. So here you can see that. Okay, let's go and run. So see, precision value for your class 0 is going to be 1, and that is correct. Okay, that is correct, right? This is a precision value for your class 0. Okay, what about recall value for class 0? Let us copy this thing. Okay, and go with the formula. Here you can see that the true negative is there. So for true negative, the value for true negative is 3, right? Okay, value for true negative is 3, and value for false positive is going to be 1. This is a false positive, right? So let us go ahead with the 1 value. Okay, so let us go and run. Okay, and here you can see the recall. Okay, this is not the class 1, this is the class 0. Okay, recall value for class 0 is going to be 0.75. Here you will see we created a classification report. We got the precision, recall, F1 score, support, accuracy, and all these things. And here you will see that, okay, we cross check with the formulas too. Okay, which means that our formulas are correct and our precision, recall values are also correct, right? Then what about F1 score? What about F1 score? As we discuss accuracy, precision, recall, support. What about F1 score? F1 score is nothing but the harmonic mean, okay, of precision and recall. Okay, harmonic mean of precision recall. So let's say sometimes, okay, if you confused about precision recall, so then simply, okay, don't get into this. Okay, because okay, initially there are a lot of things you will have to understand, right? Am I right? Initially there are a lot of things you will have to understand. So what you can do is, initially you can simply understand the concept. Okay, only try to the understand the values of the precision and recall, because you will get confused in the formulas of that. Okay, in the initially only, after understanding all the concept what is confusion matrix is, okay, if you understood this 100% of the time, okay, if someone tell you what is confusion matrix is, so you are ready to explain what is confusion matrix is, then you can go ahead with the precision and recall. Okay, otherwise, okay, like simply go with the F1 score. Now what is F1 score? So simply here, F1 score will tell you that the your model, how much your model is able to make the correct prediction about the class 0. So if let's say if your F1 score is 0.86, so which means that, okay, your model is strong enough. Because if your value of F1 score is tends to 1, then you can say your model is strong. If your F1 score value is tends to 0, so you can say that your model is not strong. So here in both the case for class 0 and class 1, you will see that the values are quite good values. 0.86 is not a bad value, it's a very good value, it's greater than 0.85, right? Sometimes people are struggling to get the 0 more than 0.8 accuracy. Okay, I'm not talking about the accuracy, I'm talking about the F1 score. If you got the F1 score which is greater than 0.85, so believe me, your model is good, right? So in simple words, you can say this thing only. Okay, if your F1 score here is high, okay, you're near about 1, so you can say yes, your model is good. Okay, and model is good in the prediction of class 0. If you're talking about class 1, yes, F1 score is also good, 0.92. Okay, so you can say that model is also able to making a model is also strong to predict a class 1 values, right? So that's how you can understand the F1 score. So if you wanted to get the value for this, okay, you can simply know the formula of harmonic mean. So what is the formula of harmonic mean then? Okay, so if you know the formula of harmonic mean, so here you can see that, okay, the F1 score for your class 1. Okay, so here you can simply use the precision and recall for class 1 first. Okay, so 2 divided by, because there are only two values, right? Precision is precision is 0.86. Okay, let us go with this 0.86 and check whether this formula is correct or not. Because like the formula is like this. Okay, if you're talking about the harmonic mean, so you will find that the harmonic mean is looks like this. Okay, the F1 score, okay, you will find that the 1 divided by, okay, 1 here your precision, okay, plus, okay, 1 divided by recall. So okay, and here you will find that the divided by 2. So after the solving this, you will find that the 2 divided by, okay, if you see that, okay, 1 divided by precision into 1 divided by recall. So you will find that again, if you solve this, okay, I'm gonna use this particular formula because this is simplest way to uh you know memorize the F1 score, because you will find that F1 score is nothing but the formula of harmonic mean. So harmonic mean you will write like this. Okay, right, like this. Okay, if you solve this again, so you will find that here precision into this precision and the recall, I would say, plus you know the recall divided by, here you will see that the precision and recall, right? Now you can simply use this. Okay, now you can put this in the numerator again, because this is a simple math step, so we don't have to worry about it. Okay, so P plus R. Okay, so this is the simplest way. Okay, again, okay, after solving this, okay, after basically why I check this, because okay, I will use this formula. Okay, so like after Sahana gave me this particular formula, so that's why I checked it whether it is correct or not, and absolutely that is correct. Yeah, so let us go with this. Okay, one, then divided by simply, okay, our precision, which is I guess 0.86 plus 1, right? And F1 score is going to be this much. Okay, let us round this up to 2 digits and let's run this. And here you go. We got the F1 score as a 0.92. Okay, we got the F1 score as a 0.92. Okay, so that is the thing. Got it, guys? Okay, so now okay, it's up to you. You can simply again you can use the same thing. You can find out the value for, you know, class 0. Okay, now you can simply use this value instead of, you know, 0.86, you can use the 0.75. Okay, and you can simply run this thing. Okay, and enter this, and here you will get the 0.86. So 0.86 and 0.92 are the same values, okay, which we got over here, 0.86 and 0.92. So here you will find that, okay, why I did all this thing, why I show you this thing by formula and all this thing, why we check this all the things, why there is a need. Because guys, in the first time, okay, when you are dealing with something, okay, you should have to understand each and everything. That's why I showed you this. Okay, now let us discuss about the decision tree. Okay, at that time, okay, I will never discuss this thing with you, because you know, in the first, okay, we already discuss about this, right? In the first we already discuss about it. Okay, so let us talk about the decision tree. So in the decision tree is yet another algorithm of classification. Okay, we can use the decision tree for the classification algorithm, as well as, you know, for doing the classification as well as for doing the regression. Okay, so this is somewhat similar, I can say, but the approach is different. Okay, like in the logistic regression we are going to use the logit function, but here we are going to use the entropy. Okay, we are going to use the entropy. Okay, then we are going to use the information gain, then we are going to use the Gini index. Okay, these are the few terms. Okay, with the help of that we will be building the decision tree. So let's discuss, let's understand what decision tree is, then simply go ahead with our coding part. Okay, so guys, okay, in the decision tree here you will see that, let's say we have the one problem. Okay, let's say we have the one problem is there. Okay, so, and what problem is that, does the person likes computer games or not? Okay, does the person likes computer game or not, right? So here you will find that, okay, here you will find that you have the data of your, you know, other members you took the data from. Okay, you check with the, you know, multiple persons now. Okay, so you have the person's data, like their age, their gender, their occupation, right? So what we are checking is that, okay, depending upon their different, you know, inputs, their different features like age, gender, okay, occupation, like that. So we are asking the questions. Okay, this is a, you know, question based model, I can say. Okay, let's say, okay, if we talking about, if age is, you know, less than 15. Okay, we got, how we got this value, age is less than 15, and then we you know, split my data. So basically we can say that, okay, just by implementing the entropy information gain is the one major. With the help of that, we can able to find that the root node. So this is my root node in simple words. Okay, this is my root node, right? And okay, from that, okay, we can say like this. Okay, we can split the data. So here, if age is less than 15, so we can say that, okay, here, okay, here the term is -1. The term is -1. So this is going to be the prediction score for each leaf. Leaf is nothing but your outcome. Okay, leaf is nothing but the outcome, right? So here you will find that, okay, first we go with the age column. Okay, we check with if age is less than 15, so we can simply say that yes. Okay, the negative score is there, which means that they are we can say that the like they don't like computer games, like that. Okay, if we're talking about the yes, okay, then we'll go and check the another feature, whether the gender, okay, is that person male or female. If yes, so yes, they likes computer games. If if the person is not male, so which is in fact female, so we can simply say that they also like the computer game, but a little, okay, not that much, okay, as the males like, right? So this is how you approach with the decision tree. Okay, so let me show you another example, okay, in the whiteboard, so you will understand again the different one. Okay, now at this time, okay, my question is to depending upon the few criterias, okay, I just wanted to decide whether I'm gonna you know the accept the offer from the company or not. Okay, let's say, okay, I did the interview of one of the company, okay, and they give me the offer later, right? So so in the first, what will I check? I will check, okay, the different things. Okay, first let me, okay, I'll check the salary. Okay, how much salary they are offering. Okay, if the salary is in my criteria, so I can accept the offer, or otherwise the rejecting the offer, right? If salary is in my range, okay, let's say whatever range, xyz range I want in as a salary, okay, in that range if the salary is there, so I'll accept the offer, otherwise I can reject the offer. Okay, then this is my first criteria. What will be my second criteria? Here you will see the second criteria. Let's say, okay, I just wanted to see, okay, the whether, okay, company is giving me work from home or work from office. Okay, work from, okay, home, or let's say work from office. Okay, so I'll check this thing. Okay, if I'm comfortable with work from home situation, so if the company is giving me a work from home, in that case I'll accept the offer, otherwise I can simply reject it. Okay, now third situation, okay, is the company near to my home? Okay, if not, so are they providing any cab facility or not? I'll be checking this thing as well. Okay, if company is near to me, and let's say I just wanna I don't wanna go with the work from home, okay, or the remote location. Okay, so what I can check is, okay, if the work is like, let's say work from office, so what I can do is I'll check, are they providing a cab facility? If yes, so I can simply accept it or reject it. So here you will see that the accept the offer, okay, or simply the reject. Okay, right? So this is how, okay, humans, okay, are just making the decisions. Okay, in the same way, Okay, decision tree is also making the decisions, right? Decision tree is also making the decision. Understood, guys? And here, okay, these are the few terms. Okay, this is going to be the root node. Okay, these are just the nodes. Okay, this thing, these are just the nodes, you know, I can say these are, okay, you will see these are just the, you know, leaf node, right? So these few criterias are there. Okay, we will have to understand these terms. Okay, what does this mean and what does this mean? Okay, so that is the thing. Okay, so that is the decision tree in short. Okay, so what we can do is we can now simply take a simple data, right, and implement the decision tree on it, right? And one more thing, guys, the data again is pre-processed. Okay, because if we go with the again the for each and every data set, if we go with the pre-processing steps, then it will be, you know, very time consuming process, right? And you know, as you know, we have the some limited amount of time. So that's why let us go and use the pre-processed data and implement the decision tree algorithm, right? It's very, you know, it's very cool algorithm. Okay, now again, as we know, guys, what are the different libraries we wanna import? Let's say we created the new notebook, so that's why we'll have to import the again the libraries. So that's why what we can do is we can use the same libraries over here. But now, okay, now we can simply, you know, change this linear model to our decision tree model. Okay, right? We just wanted to change this thing. Okay, so there are few things which are there. Okay, we can do this thing. Okay, we can simply go with the tree method is there, and in the tree method you will find that, okay, let me remove this and just use the, you know, tab. And in the tab you will find that, okay, there are multiple, you know, algorithms are there, like base decision tree is there, decision tree classifier is there, tree regression is there, then export graph is, this is the visualization of decision tree, right? Export text is there. Okay, you can export the, you know, decision trees of all the fundamentals, like how the decision tree you can create, that kind of text you can export it. Okay, then extra decision tree classifier is there, extra tree regressor is there. Okay, these are the few algorithms are there, means which means just the, you know, variety of algorithms, you can simply say. Okay, this is a classification problem because we are talking about the classification problem, right? So that's why I'm gonna use the decision tree classifier over here. So let's go and enter it. Okay, if you wanted to, you know, solve the regression problem, so you can use the decision tree regressor. Okay, okay, these are the few things. Okay, now in the data set, I just wanted to, you know, as we are coming with the, going forward with the multiple data set. So as we know, okay, each and every data set is different, so we will have to make few changes in our data set, right? We will have to make the few changes in our data set, isn't it? So at that time, okay, these are the, few things we'll have to do. These are the compulsory one. Let's go and run this. Okay, and let's go and read the data. Okay, then at that time, okay, when we are dealing with that particular situation, let's say to split the data, we need again to, import the sklearn dot model selection, import train test split method. So at that time we'll, again use that particular code to import that particular method, right? So let us go ahead quickly and import the our data. Okay, so here I'm gonna use the read. the user's data. Okay, as I shared the user data with you, so I know, okay, we will find the user data over here. Yeah, user data dot CSV. Okay, and I hope you got the the user data file as well. You downloaded it from the drive, right? If not, try to download it. Okay, now this is my user data. Okay, let's go and run this and let's see the data now. Okay, this is my tf.head. I just wanted to see the top 5 entries of my data, and here you can see the user ID, gender is there, age is there, estimated salary is there, and purchase history is there. Okay, now what is my problem over here? I just wanted to create a classification model. Okay, okay, this is the first thing I just wanted to do. Now here you can see that in my data you will find that the user ID is there. Okay, now user ID is just the is just the the nominal scale data, just the label. Okay, that we wanna uh, you know just the unique label or the unique ID, I can say, right? Primary key in SQL, right? That is my user ID, right? Then I don't want this because this is not helpful for my model building part. So what I can do is I can simply remove it, or I can simply drop this particular thing, right? So instead of dropping, what we can do is, okay, we can taking the few columns which we will be using for our further analysis, right? Then second column is gender. Okay, gender column is there again. Then we have the age, right? Okay, then we have the estimated salary column. So basically these three columns which are important for our analysis, right? These three columns which are important for our analysis. Then we have the purchased history. So basically depends upon my data of the customers. Okay, we will have to identify whether the person purchase my particular product or not. Okay, so this is my target. Okay, this is my target. So I have past data depending upon the age, depending upon the gender and their estimated salary. Okay, I will check whether the customers are preferring to purchase my product or not. Now our main goal is to what is my problem. Okay, I just wanted to build a model of classification. Why I wanted to build a model of classification? Because I just wanted to see whether customer is interested to purchase my product or not. That is my main problem. Okay, I just wanted to check whether the customers are interested to purchase my product or not. Okay, and on the basis of their estimated salary, age, gender, okay, I will check, okay, whether the customer is going to purchase my product or not. So I have the data of few customers, the past data, and the customers which didn't purchase my product as well. So I took the data of those customers as well, because they just visited to my uh, website. Okay, and just I just took the survey, okay, from those customers. Okay, so and in the survey I got these many features: gender, age, estimated salary as well. Okay, as well as we got the lot of things, right? But here you will find that, okay, we took this much only because just to show you how to implement the decision tree. That's the main aim of mine over here in this for this particular session. Now here, okay, in I'm gonna use the age and estimated salary as my independent features. Okay, age and estimated salary, because of the due to the time restrictions, okay, we'll have to go with this two salary, the columns. Okay, because here you will find that the gender column is the again the male and female column. I'll have to add the one hot encoding to change that again and do some pre-processing again. So because of time restriction, okay, we'll go ahead with only age and estimated salary, and we build the model which can predict the purchase history, right? Which can predict that person is able to purchase my item or product or not, right? So for that, I can simply split my data into as my input data and my output data. So what is my input data? Okay, df dot iloc. As we know, we use this method in the previous sessions as well. Okay, all the rows I want, but in the in the x only, I want age and estimated salary. So I'll use the age and estimated salaries index number over here. Okay, so I'll add the index number like this, the 2, because here index number start with 0, then 1, and for age index number is 2, and for estimated salary index number is 3. So what I'll do is I'll add the index number as the 3, right? So I mentioned these 2 and 3 in the list. That's why, okay, I'm able to get the output, okay, as the age and estimated salary. Okay, if I'm using this like this, okay, 2 and 3, then you will get only 2 column, not the 3. But now understand, I will be using the 2 and 3 in the list. Okay, in the list, then we will be getting the values. Okay, so I want the values now, so what I can do is dot values. Okay, I want the values only, not the name and all. Okay, second thing is that I wanted to extract the target from my data. Again, I'm gonna use the iloc method. Okay, I'll use the square brackets. I want the all the rows of my target column, and I want the my target column which is of the index 4, right? That's it. Dot values, I just want the values, nothing else. I don't want the column name and all, right? So these are my, this is my data. Yeah, now after this, after getting the data x and y, okay, here what I can do is I just wanted to split that data into training and testing. Okay, and why I just wanted to split that data into the training and testing? Because I will build the model on the training data, and I will make the prediction on the test data. So, okay, which means that I I will be checking my model is comfortable with the new data or not, right? So, let us do that. Then you will understand this thing. sklearn, okay, dot model selection, okay, import train. Here you will find that the train test split. So many things are there, guys. Huh? Okay, train test split. Now here you will find that I'll have to add the the data sets which I wanted to create from this. Okay, so how many data set I just wanted to create? I just wanted to create the data for the X train, right? I just wanted to create the data from X test, right? And remember, guys, the order for this data set is very much important. Huh? Okay, if you miss the order, you will get the wrong results. Okay, y train and y test, the order is very much important. Train test split, just add the x data, just add the y data, and I just wanted to take the my training data as a 70% of my overall data. Okay, so that's why I'm gonna make the you know set the size for the test data is going to be the 30%. So 30%, which means 0.3, right? 0.3. And basically this is going to be the splitting, but in the form, okay, in a random way. Okay, as we know, we understood what is the simple random sampling is. So in the simple random sampling, which means we are taking a samples randomly from the data. So here we are doing the same thing. Okay, we are taking the samples. First we are taking the 70%, okay, random variables, random values from my original data, right? And we are taking the 30% of my data which is totally taken by random in my test data. Okay, so 30% as my test data and 70% as my trained data, right? So, and last step is going to be the random state is there. Why? Because after doing this, I don't wanna see any changes in my accuracy. Okay, because let's say if you are working in a team, you want the the same accuracy each and every time. So then you can use the any constant value as the parameter parameter random state and that particular constant value in your team, which means your all the teams are using a random state equal to 10. Okay, then all of you will get the same results. Okay, this is the thing. Now let's go and run this. Okay, now okay, let me show you the the size for this train dot the size for this is going to be the you know 280. Okay, now what I can do is I can simply print the user data size dot shape. So I'll get the shape of my original data, then print of my extract data. Okay, then I can simply copy this thing. Okay, now here what I can do is I can simply copy the x train, then y train, then x test, you know and then y test. Okay, let me run this. Okay, user data is not defined. Okay, not user data, it's df. Okay, so yeah, so see, I'm doing this in front of you, so sometimes error will be might be there. So you will find that, okay, you will have to, okay, if you know how to read the error, then you will definitely you know able to read the error and you can solve that particular error, right? So here you go. Yeah, y test. So here you can see that, guys. Okay, initially we got the data how much, 400 variables are 400 observations are there and only 5 columns are there. Okay, out of which, okay, 4 columns are nothing but my input column and 1 column is my target column. Now here you can see that, okay, I took only 2 column as my independent data, x data, right? In my x data you will find that only two columns, and in my test data you will find that in my target data you will find that only 1 column. That's why you will see that only the rows, not the column. you know Understood? So this is the thing. Now we can do it. Okay, we can simply, here you can see that the second thing, okay, what we can do is, okay, now if you see the, let's say, okay, if you see the train data, so you will see that the range, okay, range of your first column, okay, the age column, 49, 47, 50 is there, and the range of the estimated salary is very big. It's a 5 digit number or sometimes might be 6 digit number you will get. Okay, so as compared to 2 digit number, okay, this is the 6 digit or 5 digit number. So when you are building the model, so at that time this column will dominate, right? Yes. So at the time of building the model, okay, this column will dominate, this column will have the highest weightage, right? And this column has the lowest weightage. So I don't want this kind of scenario. I want these 2 columns will be on a same weightage. So that's why what I can do is I can simply convert this data, okay, into a I can do a data transformation. Okay, so I can transform simply the range of both the data. So that's why we have the few data transformation technique. So in the that is nothing but a feature scaling. That is nothing but a feature you know scaling, right? So here what we will be doing is feature scaling. Okay, to change the transform the range of both the data, right? And then, you know, again for that, what we want, we want, you know, pre-processing. Pre-processing from sklearn dot pre-processing, import the one thing which is nothing but the standard scalar, right? We want the standard scalar, right? So this is nothing but a, you know, okay, this is the, you know, one method. With the help of that, you can transform this data into, yeah, and you can convert this into the same range, right? So that is the thing. So let's say, okay, so standard scalar you can do. uh, so I'll be creating this. Okay, I'm gonna use this. Let me copy this quickly. Okay, okay, and after this, I'm gonna use this or apply this on my train data, because you will find that we will be building the model on X train data, right? And then we will be implementing on the, you know, the test data. So that's why we will have to transform this data. So this data is the, you know, X data na, so X train as well as X train. Okay, so we will be transforming our both the data, the X train and the X test as well, right? So first let's go and transform the X train data, right? So we will be implementing stx dot fit underscore transform, right? Transform, right? So here simply add your train data. Okay, and here copy this thing. Okay, and put it over here and simply change the data X test, right? And enter this. And now let me show you the data. Now, are you able to see? We just change the data, we transform the data in the same range. Now the range for this is going to be the, you know, the range of standard normal distribution minus 32 plus 3. You will see that the your 99.997, you know, 6 times 9 means, you know, around all the data, 100% of your data we just transform into the range minus 32 plus 3. Okay, so here you will see that the your initial data is this, and you just transform the data like this. So now, okay, my data is ready. So now let's go and build the model. Okay, so as we know, we created the model, we imported the model already. So my decision tree model is this. Okay, decision tree. Now in short, let's go with the model name. Okay, and as we know, the name of our model is going to be the decision tree classifier, right? Right, so this is my model's name. Okay, now what I can do is I can simply use this model to fit on my data, right? That we did in the logistic regression as well, right? So this is the thing. Okay, so here you can see that now we are using the extend, okay, data to, you know, make the model which can predict my y column. So we will be using this x and y data of the train for building the model first. So let's go and run this, right? So here you will see that I'm gonna run now. Okay, run this. Now here you can see that fit missing one argument, positional, you know, why no, this is the method, this is not the attribute, right? Yeah, yeah, this is the method, this is not the attribute. Yeah, done with the, you know, the thing. Yeah, now, okay, what we can do is after building the model, our aim is to go for the prediction one, right? So we can simply go for the prediction one. Here you can see that we are just making the predictions now. You know, the we are using the model dot pred. Okay, model dot predict, and here we are simply, you know, implementing our X train data, and we will be getting our, you know, predicted values. So we can use that predicted values to build the confusion matrix, right? Okay, going to build the confusion matrix, and in the confusion matrix we are using the y train, my target column, actual target column, and my predicted target column, y train predict, right? And let me go and see. So this is the first thing. Now what will be the second thing? Simply copy this, okay, and transform this at the classification report, okay, and make the use the print function, right? And let's run it. And here you can see that we got the output, and you know that how to rate the accuracy, precision, recall, F1 score, support. I told you already. Now this is for the train. Okay, so you can do the same thing for the test as well, because we created the model, so you can do the same thing for the test. So let me quickly show you, and then we will stop, guys. Now here, let us use the test. Okay, we are going to make the prediction of the new day for the new data set. Okay, test is not, okay, test is my new data set. See, okay, we created the model, we build the model on the train data. You see that the train data we took. Okay, we didn't touch the test data, right? We didn't touch the test data. Now we are using the test data to make the prediction of my, let's say, my model now using or handling the new data now, right? So that's why I'm gonna show you the results for this. Okay, so let me change this to train to test, and let me go and run this, then you will understand. Okay, here you can see. Okay, now initially my model is able to make the predictions, okay, 100% of the time correctly on the train data. But when it comes to new data, okay, new data that my model don't know about it, so at that time my model is able to get the accuracy only 85%. So you see the some kind of drop over here, some kind of drop over here. So you will find that for the new data set, for making the prediction about the new data set, you will find that some kind of less accuracy. Okay, so guys, that is it, how we can build the model and how we can check the model's credibility. Okay, credibility. So here you can see that the 85% accuracy is that for the for the prediction of new data set. Okay, so guys, that is it about the today's session. Thank you, guys. Thank you very much.